A 1,400 kilogram car is moving west with a velocity of 15 meters per second when it collides with a pole and is brought to rest in 0.13 seconds. What is the net force exerted on the car during the collision? And there's a hint here. Why don't we solve for acceleration first and then use Newton's second law in order to figure out the force? So, if I look, there is a car that has 1,400 kilograms, and in the beginning it is moving in this direction at 15 meters per second. But at some point it hits a pole and has a new velocity. It says right here because it's brought to rest. So I know its velocity equals 0 meters per second. I know that the amount of time it happens is in 0.13 seconds. So I think I'm ready to identify some givens. First, the mass of the car equals 1,400 kilograms. The velocity initial of the car is 15 meters per second. The velocity final of the car equals 0 meters per second. And the time equals 0.13 seconds. Now, eventually, I want to know force, and that's going to be in the units newtons. But in order to do that, I'm going to find out what acceleration is first, meters per second, because a hint told me. And so I'm going to use two equations. I'm going to use the acceleration equation, which is velocity final minus velocity initial divided by time. And once I have that, then I'm going to use Newton's second law. So, in order to figure out acceleration, my acceleration equals my velocity final, which is 0, minus my velocity initial, which is 15, over 0.13 seconds. I find out that my acceleration is negative negative 115.4 meters per second. And if I know that, force equals mass, which is 1,400 times negative 115.4. Thank you. No worries. I find that my force net, when I do the math, equals negative 161,538 newtons. Now, if I apply significant figures, I get a number negative 160,000 newtons.